So today we're going to look at the last two ways to prove triangles congruent, and we'll do several practice proofs. So what are the ways that we know that we can prove triangles congruent so far? I'll take people's hands. Yes.
Side angle side.
Side angle side, yep. Yes, sir. Side, 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 yep. And yes. We haven't learned that one yet. Yes? Yeah, angle, side, angle. Those are the ones we know so far. Okay, we talked about it earlier today, but remember, side, side angle, not a thing. You can't use side, side angle. You also cannot use, every now and then I have a student who decides to do this, you can't use angle, angle, angle. AAA is a car service. It doesn't help with congruent triangles.
Wait, why is angle, angle, angle like not a thing?
It's a good question. Let me show you.
Because really, you can have the same angles but not the same sides. That's facts.
My God, I wasn't asking you.
So could I have two triangles like this where all the matching angles are congruent, but none of the matching sides are congruent? Like imagine if you take a picture of something. Is the picture the same size as the original object? No. The angles are the same, but the sides are not, so they're not congruent. So that's why angle, angle, angle doesn't prove triangles congruent. It does prove that they're similar, though, and we'll talk about that next semester. Yes? Yeah. All right, so we're adding two new ones to that list today. The first one is angle, angle side. The only difference between angle, angle side and angle, side, angle is where is the side? They both have two pairs of congruent angles and one pair of congruent sides, but an angle, angle side, the side is not in between the two angles. An angle, side, angle, the side is in between the two angles. So in the diagram, see, notice here that TS is not in between angle R and angle S. So that's why this is angle, angle, side, because this side is not between these two angles. Okay? Any questions about that? All right. Then parts of a right triangle. I find that students sometimes forget the names for the parts of a right triangle. In a right triangle, the two sides that make the right angle are called the legs. The side across from the right angle is called the hypotenuse. Please do not do what a student earlier today did and ask me what is a hypotenuse when we're on page 2. It's like, really? Okay. So, hypotenuse leg is the last way we can prove triangles congruent. And it says that if the hypotenuse and one of the legs, it doesn't matter which one, of one right triangle are congruent to the corresponding parts in another triangle, then those triangles are congruent. Notice that in order for this to work, you have to have a right triangle. If you don't have a right triangle, you don't have a hypotenuse. If you don't have a hypotenuse, you can't use hypotenuse leg. We'll see this come up in a couple of the proofs that we do. Okay? Notice also, someone may go, well, isn't that side, side angle? Because it's two sides and an angle that's not between the sides. This is the case where side, side angle does work. It only works if it's a right angle. And we call it hypotenuse leg, because we can't use side, side angle because it doesn't work all the time. So let's do some example proofs. I'll do this one as a 2-column proof. So we've got UM bisects angle JUP, and that angle J is congruent to angle P. So I'll take a suggestion as to what we could or should do next. Micah?
You can say angle JUM is congruent to angle NUP.
Yes. Do you know the reason for that? Yes, that's the definition of angle bisector. So notice it said JUP, which has a vertex up here, so the two congruent angles should also have their vertices up there. Now you had a question or a thought for us? Okay. When you say UM, what do you mean? Yeah, what is it? Which is it, a line or a segment? Okay, so segment UM. Yes. What's the reason? Reflexive who? Yes, the reflexive property.
So why you make it feel like so?
Exact?
Yeah.
Yeah, things have to be right. They can't be kinda. One of the things you learn in geometry is to not do things kind of halfway.
So far, some know how to do basic math.
So, someone have a suggestion as to what we could do at this point? Madeline?
Triangle JUM is congruent to triangle PUM.
Yes. What reason?
Angle side.
Yes, that is angle, angle, side, because you've got two pairs of congruent angles and a pair of sides that are congruent that are not in between the two angles. In between the two angles would be like this side and this side. But we don't have those. And once we have the triangles congruent, we can say that any of the corresponding parts are congruent. Segment JU is congruent to segment PU by the definition of congruent triangles. So is there something I can help with?
I really get a chance. But why isn't PX and then the U?
Wait a minute. Say it again. Someone was rustling papers. It wasn't you. What?
Why isn't angle P and the X for reflective and then the U on top, the angle U, whatever? Why isn't it angle side angle?
Okay, to be angle side angle, the side has to be the side that connects the two angles. Does this side connect angle U and angle P? No. So when we say angle side angle, we're saying that this side connects these two angles. Okay? All right, let's go on to the next one. I'll do this one as a flowchart proof. If you really hate flowchart proofs, feel free to do it as a 2-column. take a suggestion from someone who has not given me a suggestion so far today. Eventually, when we run out of people, I'll start calling on people. Yes, Garrett. Segment SN is congruent to segment NO. How do you know that?
Angle SNW is congruent to angle W.
And what's the reason for that? Okay, so you're combining two things. It's a common mistake at this point. The definition of perpendicular lines, does it say anything about angles being congruent? It just says that you're going to have what? Right angles. So we're just going to say those are right angles to start with. So angle SNW and angle ONW are right angles. That's what the definition of perpendicular lines tells us. But if you've got perpendicular lines, you have to have right angles. Then from there, if you want to say the angles are congruent, you can. Angle SNW is congruent to angle ONW. Can someone tell me what the reason for that statement is? Yes.
All right angles are, all right angles are.
Perfect. All right angles are congruent. I guess you should start marking things on this. Let's see, these are right angles, and they're both congruent to each other. Yes, Rivers? Yes. For what reason? Very nice, thank you. All right, and here's where some students will frequently make a mistake. Because they want to prove the triangle's congruent. How many pairs of congruent sides do we have? 2. How many pairs of congruent angles? 1. Is it side angle side? No. And side angle can't be used to prove triangles congruent. And sometimes people think, well, then I'm stuck. But anytime it looks like it's side angle, but it's a right triangle, it's going to be hypotenuse leg. But before we can say the triangles are congruent by hypotenuse leg, we have to state that we have right triangles. How do I know I have right triangles? Because they've got right angles in them. So from this statement, I'm going to say triangle SNW and triangle ONW are right triangles. That's the definition of a right triangle. It's got a right angle in it, it's a right triangle. I guess I should say if a triangle has a right angle in it, it's a right triangle. Now I can bring these 3 things together to say that triangle SNW is congruent to triangle ONW, and that will be because of hypotenuse leg. We're not quite finished. Once we prove those 2 triangles congruent, notice S and O are corresponding parts, so they will be congruent. Angle S is congruent to angle O by the definition of congruent triangles. Keep doing that. I want to point something out to you before we go on to the next one, and that is, did I really need this step? Did it lead anywhere? No. So if you had been thinking far enough ahead to realize that it was hypotenuse leg, you could have left that step off. It's not wrong if you write it down, though, because you've given a valid statement and you've given a valid reason for it. If you do that on the test, if you want to cross it off, you can, or I will. It doesn't matter. You won't get any points taken off either way. But we just didn't need that step. Most of the time, we need to say that the right angles are congruent, but for hypotenuse leg, we don't. Again, it's not wrong if you have it. I'll just mark it out. As long as it's true, it's not a problem. All right. Let's see how far we can get with these. Seem to remember this one being kind of long. Oh, sorry, that's not step 2. Still part of the given. Sorry about that. All right, Carson, give me something I can do from here.
LR is congruent to LR.
All right. Yeah, everybody can find that one now. LR is congruent to LR by the reflexive property. What's the other thing that you need to look for in the diagram that comes up? Nobody remembers? Vertical angles. Always look for vertical angles also. In this case, there aren't any, but that's the other part. All right, I'll take a volunteer to give me another. Yes, Evan.
Angle FLR is congruent to is congruent to angle RLY by definition of angle bisected.
Okay, be careful. What angle's being bisected? So if we're bisecting the angle down here, the two halves should also have their vertex down there.
Okay, so angle LRF is congruent to angle LRY by definition of angle bisected.
There you go. That's one of those things you just have to be careful about. Thank you. Do I have enough to prove the triangle's congruent yet? Not yet. What else can we do here? Yes, Micah. Good. Angle F and angle Y are right angles. What's the reason for that? Yeah, definition of perpendicular lines. Yes, Maisie. By what reason? Well, we do have the hypotenuses congruent to each other. This is the hypotenuse because it's across from the right angle. But do we have either of the legs congruent to each other? No, not yet. So one of the things to be careful of is when people learn HL, they want to use it all the time, anytime you have a right triangle. And it doesn't work on this particular one. We have to have something else. Yes?
Angle F and angle Y are congruent to each other.
Yes. Angle F and angle Y are congruent to each other. What's the reason for that? It's okay. She didn't see
All right
me.
angles are congruent.
Yeah, all right angles are congruent. So Sierra, do you know why the triangles are congruent now?
Oh, I was gonna say the hypotenuse.
But it's not hypotenuse leg because I don't know the legs are congruent. I know the hypotenuse for both of them are congruent to each other, but the legs are these two sides and these two sides, and I don't know any of those sides are congruent. Okay, Jeffrey?
Would it be because angle side?
It would be angle side. And if I name the first triangle FLR, how do I have to name the second triangle? YLR. And then segment FR is congruent to segment YR by the definition of congruent triangles. Any questions about that? No, it's not. Let's go on. So I'll do this one as a flowchart proof. So JA is parallel to CK is given. And angle J is congruent to angle C, also given. And I'll go ahead and do the easy one. AK is congruent to AK by the reflexive property. That has come up a lot today. Is that enough to prove the triangle's congruent now? Not yet. Micah? I'm sorry, what was the second one? CKA? I just couldn't hear it. The air conditioning kicked on right as you were saying it. So angle JAK is congruent to angle CKA. What's the reason for that? Yeah, the alternate interior angles theorem. Now we have enough to prove them congruent, yes.
AKJ.
What about A? Are you talking about angle? AJ? What are you talking about?
Triangle.
Oh, well, didn't say so.
Triangle AJK. I mean AKJ.
AKJ? You can name the first one any way you like.
Okay. It's going to triangle.
Chief.
So notice in this triangle, AJK, A is marked with 2 arcs, right?
Okay, so go KCA.
J matches up with C.
Oh, KC. Hey, bro, you can't be saying what I'm trying to think, bro.
KAC.
Yes.
Someone tell me what's the reason for that? Yes, Cameron. Yep, it's angle, angle, side. And then that's enough to then know that the corresponding parts are congruent. JK is congruent to CA by the definition of congruent triangles. I don't think we have quite enough time to do the last one, but let's go through the logic of it real quickly. So since I've got perpendicular lines, what am I going to have? Right angles. So I'm going to have a right angle at T and a right angle at I. If G is the midpoint of TI, then what's going to happen? TG is congruent to GI. What else can I add? The vertical angles are congruent to each other. And then I can add that the right angles are congruent to each other. So what? It would be an angle side angle proof. Yes. All right. Let me go ahead and give you your assignment.
Oh, wait. No, I know, but like, I'm thinking not in
Yeah, you gotta test it out.
Yes?